Hello, everyone, and welcome to the Digital Innovation and Nature Conservation Podcast. Today, we're having a discussion on the present and future of the use of genetics for conservation with Misa Winters, Molecular Lab Manager at Conservation X Labs, a technology and innovation company that creates solutions to stop the extinction crisis. So, without further ado, let's get into the content of this podcast.
To start the conversation, first, could you tell us about yourself and what Conservation X loves to do and its mission?
So my name is Misa Winters. I have a master's in zoology, and I currently work for Conservation X Labs as the lab manager as well as the senior development scientist for species ID identification assays, which are applied to the product that we've developed, which is a nucleic acid barcode identification tool. And then my background is in wildlife genetics, and I've been doing conservation work for over 8 years now, and I just absolutely love it. So Conservation X Labs is, at its heart, it's a conservation technology company that is focused on innovation and driving up, scaling up great ideas that are going to have really big impacts quickly. Because that's sort of, as we're facing some of these, climate change crises, and most specifically the loss of species, the sixth mass extinction, which is, caused by a single species, humans. That's what Conservation X Labs is trying to address. We want to create technologies, advance ideas and thought leadership in that sector so that we can create amazing solutions that can quickly have impacts and effects, like I said, on these drivers of extinction.
Could you tell us about the NABIT project and its mission?
I think it's been about 5 or 6 years in the making, in terms of when it was first thought about. And the NAVIT stands for Nucleic Acid Barcode Identification Tool. And this just means that the whole goal is to make a field-ready, portable, affordable, handheld product that you could take anywhere and be used by anyone and do species identification. So you don't have to be a technical user, you don't have to be a scientist. So the goal is just you just have this one device and you take it anywhere and you can answer this yes or no question of, is this species present or not? The other big applications that we started focusing on in the initial period was seafood fraud, because this is actually very common. It's the same issue as timber. A fish is caught, it's filleted, it's being sold as X, but it's actually Y. And the biggest reason why we're passionate about the NABIT and the development of it is that we want to democratize the use of DNA, and we want genetic resources to be a bigger thing. We want people to feel more engaged in what it means to use genetics and to be curious about the world around them.
So how do you see your NABIT technology in 5 to 10 years?
In 5 to 10 years, we hope that the NABIT is empowering a huge array of people, whether it's law enforcement, customs agents, global citizens, scientists, or just basic citizens anywhere. The whole idea is that if you have this affordable technology and tool that can that can answer these questions about what is this thing in front of me, then again, that's where you're democratizing DNA. More specifically to technology, in terms of 5 to 10 years, we hope to have a vast array of products, things that are addressing some of these more difficult sample types. From my perspective, from my background, I want to see it in wildlife trafficking applications. I'd love to find a way to make it be useful for ivory, pangolin scales, bones, teeth, etc. The opportunities are endless.
We heard that you were engaged with the project of using DNA extraction to identify elephant poaching hotspots. Can you tell us a bit more about the project? What would be some of the challenges or more so ethical dilemmas you have personally faced in your work in the past?
This is one lab focused on a single species, elephants, African elephants specifically. And African elephants, there's 2 species. There's savanna elephants and forest elephants. And they have been under massive threat of extinction due to poaching for their ivory. So the approach in this lab was what tends to happen is, poachers go out, the elephants get killed, their tusks are harvested, and then that ivory is shipped typically from Africa into Asia, but it also goes to Europe, the US, it goes all over, but like the most common place it goes to is Asia. It's in the headlines all the time. They seize ivory, meaning that they catch the shipment in somewhere along its route, and they take it, and then they start investigating. And typically they don't have much success in, attaching some kind of culprit or perpetrator to the ivory, And so that's where we sort of were asking the question, like, okay, can we use the genetics to understand how the ivory is moving, where the ivory is coming from, and whether that can inform these, criminal law enforcement agencies on like where to look for said criminal activity. We kind of developed a protocol for getting the ivory sampled from the seizure, because the seizures can be thousands of tusks, and that can represent, thousands of elephants, obviously. So it can be really depressing in that way. But so we would ask that they would send like a small piece of the tusk back to our lab in the US, and then we would do this allele analysis. So we would look at genes from their nuclear genome, and we would do kind of like, it's like DNA fingerprinting. It's just like what forensics do when they take your DNA and try to find perpetrators, right? So we have a DNA fingerprinting like technique for elephants, and that's based on a reference data set. And that comes from, we worked with all of these rangers and organizations across Africa, and they literally sent us little vials of elephant poop for years and years and years. And that's how we determined the genetics of like these individual populations of elephants all over the country, or all over the continent rather. And then we also started seeing that wherever the elephants came from, where the tusks came from, they were never shipped from that same country. And so you can tell there's like an organization happening here. So the elephant is killed, the tusks are moved to a different country, and then moved typically to another country, and then that's when they're shipped into Asia. So again, it's kind of one of those fascinating things. You're saying, okay, we can tell from the genetic signature how the ivory is moving, and therefore now you can point to the fact that, okay, yes, there's a poaching hotspot, right? It was, at the time, it was centered in Tanzania for savanna elephants, and then centered in like Togo DRC area for the forest elephants. So, you want to think about like, how do we empower the situation on the ground so that hopefully we can prevent it. And we know that there's human elephant conflict in a lot of these areas, and a lot of the people that live in these areas, they don't see conservation isn't something that's going to matter to them in the same way, because for most of them, just basic needs, food, water, shelter, is their day-to-day life. So why would they care about this giant elephant that's raiding their crops? And then again, we've found that it was an organized crime thing. Like, they used the elephant tusks to launder their money. So it has nothing to do with the general people and their welfare. It has to do with large criminal networks. So it's just this big, giant ball of yarn about like, which string do you pull to start solving this problem? Not really sure.
What do we have to be careful about to promote digital technologies for nature conservation?
And so actually, I'm going to use this as an opportunity to plug one of the other directed innovation projects at CXL, which is called the Sentinel. And this is a project where they're using AI and machine learning to create these algorithms for camera traps. So this is a very common thing that conservationists use, right, in order to kind of see where species are and how they're moving and how they're interacting. You have to kind of set up cameras, and a lot of time what happens is they get set up for a few weeks, a month, and then someone has to hike out into the woods and retrieve it, and then someone spends hours watching all of the images and being like, oh, there's a thing, and then you're recording it, right? So obviously that's not a very rapid or quick way to get information. So the idea behind the Sentinel is to, like I said, create these algorithms. You use AI machine learning, and what we want to, because like people can already do this, but you have to have a certain skill set, right, in order to be a programmer and understand how these algorithms work. So what the Sentinel is trying to do is like automate that process. So the problem though is it's always the unintended consequences. We talk about this all the time. We make things for good, and then they can be used for bad. And sometimes you don't even know what looks like. In this example, it's pretty clear. You would, if you're saying, oh, we're going to make like a public access portal, and literally all you have to do is type in a species of interest, and we'll pull up camera data with locations attached to it. And so if a poacher were to do that, they could, in theory, it would make it really easy for them to like, oh, great, here's some pangolins. We're going to go over there and get some pangolins, or here's some elephants. Let's go over there and get some elephants. So, that's kind of an obvious one, and it's one that maybe we can put, data security things in place, or, you have to verify accounts before they can search for certain types of animals. Like, there are things that can be done. But, there's kind of these broader issues too when you talk about digital technologies and whatnot, because a lot of times what motivates someone to use a technology is because it aligns with some kind of financial interest, right? Like, they're paying for this service or they're paying for this product because it helps their bottom line. And sometimes the intention of the product is very different from the bottom line for the reason why someone would pay for the product. And if those interests don't align, then that's where you have some problems. Maybe one example would be, like if you're using digital technology to monitor like a coral reef or something, and it's like that same thing. If someone wants fish because they want to sell it for an aquarium, sometimes it's good. It's like, okay, here's where they are. You can go out and harvest them. But if you're not looking at the broader implications of like, are we sustainably taking fish out? What kind of impact does this fish have on the reef, et cetera, et cetera? Again, we're always combating capitalism a little bit. And that's for me, I think, the biggest thing to think about with digital technology applications.
Do you have any last messages for our students who'd like to work in the field of nature conservation?
But for students, the advice I give is like, you can be really passionate about whether it's conservation, ecosystems, climate change, whatever it is, but you don't have to be a scientist. You don't have to be an engineer. Like, if you love photography, great. You can become a storyteller for conservation stories. You can be a storyteller for innovation. You can use that skill set and that passion for that effort. Absolutely. I think it's about having conversations. You don't have to just be wedged into like, this is what my vocation is and this is the extent of it. Absolutely not. You have conversations with others. Chances are you'll find some common ground. You'll have something to share and provide that someone will never have thought about. That's the whole point. Like, you can't synergize unless you have diversity in your voices, diversity in your experiences. So whether you're volunteering in conservation work or you're trying to find a place where you can use, like I said, your skill set into conservation purposes, into nature conservation, there is a way. It can be challenging, but there is a way. And you don't just have to be a scientist or an engineer to have an impact, 100%.
Thank you for listening to this conversation. We will leave you with one last message from Misa.
So easy to get stuck in the doom and gloom, right? Like, situation, you can read any news article and it'll immediately depress you. There's so many things going on that are difficult to understand, and it's frustrating because you don't necessarily see anything happening. But there are people working, and if the more we all talk to each other, hopefully we'll see more of like the people who are already trying to engage in these problems, the people that are trying to be like, this can be more of a global effort. This could be something that isn't saved just for scientists to work on, just for conservationists to work on. Like, we can make it a global effort and come together and solve these big problems. So optimism is important. And so is, believing that you can do something, but you can't do it alone. So we got to talk to each other.